Please, a big applause for Joe Dixon.
All right, hello everybody. I tell you, the first thing I needed to come on stage this morning was a nice salty mouthful of yeast extract, when my mouth's going to be pretty dry throughout this anyway. But yeah, good morning. I hope you've all slept well, had a nice evening. Not sure if you feel more nervous right now coming on stage or yesterday when Taylor let you lot loose with the emoji buttons on the Reverb website, but it seemed like that went pretty well. So I just want to kick off things this morning, as we do every morning in the Laravel team, by saying good morning. And I've forgotten the sound. Pretend you didn't see that. Now I can't type. I'm going to say good morning, James, morning, Dries, morning, Jess. Appreciate the support, but not a great time. So I am Joe, and as Kaneka said, I am one of the Laravel core team. In case you didn't realize, that's me there on the right-hand side. I work predominantly on Vapor, Laravel's serverless deployment platform. But more recently, I've been kind of spreading my wings a little bit, and I want to talk to you a bit more about that today. I live with my wife and 2 kids in a small city in the UK called Norwich, where we're lucky enough to have 2 cathedrals, 1 castle, and the best football team in the world. Which is great for me because when I'm not behind the keyboard, I enjoy to watch football almost as much as I enjoy Formula One. Ah, good, he got a laugh. Almost as much as I love to drink coffee. And that's really all there is you need to know about me. So let's kick off proceedings this morning by addressing the elephant in the room. And I know you're probably all sat there thinking, Joe, I came away to LARACON to take a break from Slack. Why have you brought me straight back here? And I promise you there's a good answer for that. But also, just count yourselves lucky that I didn't subject you to a session played out in Teams. So the good reason for why we're in Slack today is that we're going to be talking about real-time Laravel and how we can use the tools in Laravel and the surrounding ecosystem to build really, really engaging, real-time user interfaces. And so I haven't brought a keynote presentation here today. I haven't brought a PowerPoint presentation or Google Slides or anything like that. My slide deck is an app built with the tool stack. Now, in case you've been living under a rock, the tool stack is Laravel, Livewire, Alpine.js, and Tailwind CSS. And throughout the course of this morning, the next, 27 minutes or so, we're going to be talking about, we're going to be using this skeleton application and bringing it to life, bringing in real-time communication elements. And there's a number of different technologies that we can use to build real-time communication. But today I want to talk about, in particular, about WebSockets. So I'm going to jump over here into the WebSockets channel. And we probably want to know a little bit more about what WebSockets are. So let's see if we can ask the team. What are WebSockets? Can't type on stage. Fingers are not working. Oh, good. OpenAI enters the chat, so this should be helpful. So WebSockets provide a full duplex communication channel over a single long-lived connection between a client, usually a web browser, and a server. This allows for real-time communication where both the client and the server can send messages independently at any time. WebSockets offer a more efficient and responsive alternative to traditional polling techniques. That's actually a really nice explanation. It's one of the few times that ChatGPT got it right for me. But it's quite a lot to take in one go, so let's dig a little deeper. And to start that journey, let's talk a little bit more about techniques for kind of near real-time communication that we might be more familiar with. I'd like to talk about short polling. Now, in short polling, we have a client and a server. And the client makes requests to the server on a periodic basis to ask for updates to see if there's any new information available. And that starts with an HTTP request to the server, asking for the data that it needs. The server will then take that request, go through the HTTP handshake negotiation, grab the data if there is any, and send it back. And then we wait for an indeterminate amount of time until we kick off that process again and again and again. And depending on how long that wait is in the middle, we can kind of get to near real-time communication. If we're making regular requests, we're going to get that data more frequently. And if you need an analogy to kind of really hammer this point home, you can think of this like You're about to kick off a 5-hour journey with your kids in the back of the car. And we all know what's going to happen 10 minutes in. We're going to hear rumblings from the back. Are we there yet? Are we there yet? Are we there yet? For the remaining 4 hours and 50 minutes. I think we can do better. So this is what a WebSocket looks like. Again, we still have the client and the server, and everything still starts with an HTTP request. It's just a slightly different type of HTTP request where the client asks the server to upgrade that to a WebSocket. There's a slightly different handshake negotiation, and assuming all of those things work out, we have an open WebSocket. And I like to think of that as a pipe between the client and the server that remains open for as long as either needs it. The client is free to send data to the server as and when it needs to, and the server is free to send data back to the client as and when it needs it. And to extend the analogy that we had with the kids in the back of the car, we can perhaps think of this as the kids have now grown up, and they know not to ask that question. They're going to get that information as and when we have it available. So let's take a look at what the WebSocket request actually looks like. So it starts life as a standard HTTP GET request. We have standard headers like the host name, cookies, anything that we want to send across, or most things. But we have a couple of headers that we're probably not used to seeing. We have the upgrade header where we're requesting a WebSocket connection. The client is going to send a key to the server, which the server is going to use as part of its handshake negotiation. And we can send additional pieces of information, such as the version of the WebSocket protocol that we're interested in using, or any sub-protocols that the server might have available for the client. So the server's going to receive this. It's going to make sure that it's from an origin that it's expecting it to be from, or it's happy for it to be from. It's going to make sure that it can support the version of the WebSocket protocol that the client is asking for. And assuming all those things work out, it's going to calculate a hash using that token that the client has sent across, and it sends that back in an accept header, which the client then uses to verify the request is correct. And then all those things work out, we have our open pipe. We have a way to exchange data between client and server. And what we end up with an approach like this is reduced latency and increased efficiency. So we're not having to wait between requests. We're getting that data when we want it. And we're increasing efficiency by not making multiple requests to our server and going through expensive HTTP requests every time. And so Laravel has, as Taylor mentioned yesterday, for the last 8 years had support for broadcasting from the framework itself, and with at the front-end companion Echo, we can kind of communicate with WebSockets. But we wanted to kind of complete that package. We wanted to add something that meant from your Laravel application, you could have access to real-time communication without having to go elsewhere. And so today, I'm incredibly excited and proud to have the opportunity to show you a little bit more about Laravel Reverb. So what is Reverb? Well, Taylor mentioned it yesterday. It's a WebSocket server which you can run alongside your existing Laravel application. It's an artisan command away, PHP artisan reverb start. And that's all you need to do. And you can probably guess now from the fact that it's an artisan command that it's built with PHP. It uses React PHP's event loop under the hood to allow us to manage those those long-lived connections. And it's built to scale. Now, we're aware, like most things in software, that people's mileage out of pieces of software can vary depending on things like the amount of resource available on the server, the number of connections we need to manage, and the amount of data we're sharing between those connections. And so we've worked really hard to try and make this work for everybody. So we've done stress testing with simulating different loads of traffic, and then profiled those applications to make sure that we have had the possibility to iron out any potential bottlenecks or memory leaks. And we actually already have Reverb running on both Forge and Envoy, and the server's not even breaking a sweat. So we're pretty confident that Reverb is able to scale to meet the demand of even the most demanding of applications. But if you do outgrow a single server setup, one of the prerequisites when we built Reverb was to be able to allow it to horizontally scale. So from the get-go, you're able to deploy a fleet of Reverb servers, which you sit behind a load balancer, which will distribute the connections between those servers, and you can rest assured that Reverb is going to orchestrate all those connections to that fleet of servers that you have on your behalf. It's multi-tenant out the box. So again, I mentioned that we're already running it on Forge and Envoy. What we're actually doing is we have a brand new Laravel application running Reverb specifically for our WebSockets, for our internal applications. And so with a small configuration change within Reverb itself or within our Laravel application, we're able to do that. We're able to create different tenants and have Reverb manage those connections and keep them segregated from each other. It's pusher channels protocol compliant. So at the moment, Laravel's framework broadcasting capabilities are all kind of based around the pusher channels protocol. It's an open protocol that you can go and read about on the pusher website. And so, excuse me. And so with Reverb, you're able to drop it into an existing application that you may already be using broadcasting with a different provider, and Reverb will just work. There's no changes that you need to make. And another nice thing about Reverb is the fact that you own everything. So you're not having to worry about any sensitive data that you might be sending to any third parties. You're going to own all that data and control the data that's going across your WebSocket server. So we're going to go and have a look at Reverb in a bit more detail now. But I just wanted to walk through the installation steps. So the first thing that we have to do is install Reverb. It's a composer require Laravel Reverb. As Taylor mentioned yesterday, this will actually become a two-step process when Laravel 11 is released because we won't have to enable broadcasting. But at the moment, you go into your app.php configuration and you uncomment the broadcast service provider class to enable broadcasting. And then we install Echo, Laravel's front-end companion for communicating with WebSockets, and we're good to go. Okay. So, can everybody see that okay? So this is what we're going to be working on now. This is a new channel within my slide deck, which is completely done. I'm logged in on the left-hand side as Taylor, and I'm logged in on the right-hand side of Jess. And what we want to do by the end of this session is to have the two communicating with each other. It kind of works now, but nothing real-time is happening. So I can go in as Taylor and say hi. And you'll see that we're using Livewire. It's calling the Livewire update endpoint. So the message has been sent. It's been stored in the database, but nobody is seeing it until I go ahead and refresh the page. So what we want to do is bring this to life. And we're going to do three things today. Three are probably arguably the most important things in Slack. We're going to obviously want to deal with the real-time messaging, sending messages to each other in real time. We're probably used to seeing typing indicators, so I want to know when Taylor's typing so that I don't type over him and confuse the conversation. And depending on whether you prefer, or whether your company works asynchronously or synchronously, you may not even like this feature or use it, but we're going to talk about presence indicators. So here I've got a list of all of the Laravel team members which are here at LARACON. Apologies if I missed anybody off, I'm hoping I didn't. But they're all offline at the moment. And we obviously know that both me and Taylor and Jess are all online. So we're going to make that work. Just going to switch back here. OK. So I mentioned that Laravel's broadcasting capabilities work on the concept of channels, which is quite nice when we're talking about channels in Slack, because there's a nice synergy between the two. So if we think about the Reverb channel here, we probably need to make sure that people are authorized to access this channel. So we're going to use a concept of a private channel. And a private channel is, if you haven't used broadcasting before, there's kind of an authentication process which has to happen before you're allowed to connect to the WebSocket. So I'm not going to go too far into the details of how to wire that up. That's all very well documented already. But we'll talk a little bit about how that works in a minute. And we can use private channel for the sending and receiving of messages, and we can use the private channel for the typing indicator. The idea being that people who can't access that channel won't be able to see those things happening. The presence channel is a little bit more difficult because we need more information. We need to know when we first connect to Slack who is currently online. So we want to know that when we first connect to the WebSocket. And we also need to know when people leave and when people join so that we can update that list accordingly. So those are kind of the three core things that we're going to look at over the next 15 or so minutes. Kaneko didn't get me enough water. I blame the Marmite. Blame the Vegemite, sorry. That was a bad slip of the tongue. Okay. So that's what we're going to do. Let's go and look at some code. So the first thing we want to do is jump into our editor. I'm going to kill that. And I'm going to kill that. We want to start Reverb. So I mentioned it's an artisan command. We're going to do php artisan reverb start, and I'm going to pass the debug option. That's our server started. That's all we need to do to have Reverb up and running in our application. Let's close that for a minute. We'll come back and have a look. Then I mentioned we're going to use Echo to wire up the front end. So in our bootstrap.js file, this is typically where it happens. It's in there at the moment, commented out, so you can just go ahead and uncomment this, update your configuration, and you have Echo instantiated. We're going to add Echo to the window so that we can access it easily from our blade views. OK. So then we have a single Livewire component, which we're mostly going to be working in over the course of the talk. And I mentioned we're using Livewire. What I didn't mention is I'm also using Vault. And if you haven't used Vault, I really recommend checking it out. It's a fabulous developer experience. And it's also really nice for presentations like this because I can show you everything without jumping around into different files. So let's have a quick look at how this is structured. We just have two pieces of state. It's a pretty simple component. We just have the channel that we're currently in and any messages which have been sent to that channel. We then have, when the component mounts, we're just going to grab the messages from the channel. And we have a single action, which is to send a message. And all we're doing is calling a send method on the channel model and passing through the user and the message. And we'll look at that in a little bit more detail in a minute. Then we have some HTML or some Alpine. And the only bit I really want to show you here is that all that we're doing is iterating over the messages on within the Livewire component, which we get access to for free because we're using Alpine. And then we're going to jump down into the Alpine itself, and we're going to have a quick look here. So we have this channel object configured. So all I'm doing is, if you have used Alpine or haven't used Alpine, there's an X data attribute that you put on your component, and I'm passing this channel in. So this is kind of maintaining all the state and giving me all the functionality that I need. So I have a few properties, whether I'm currently typing, whether any other users are currently typing, the channel that we're currently connected to, and then the more interesting part. So in this listen for events, that's where we're going to be doing most of the work. So the first thing that we want to do is connect to the channel. So we're going to use echo.private. It's a private method. It's the private function which will handle all of the authentication and authorization behind the scenes. What actually happens is when you try to connect to a private channel, Echo will make a request to Laravel's broadcasting auth endpoint, and that will pass through the currently logged in user and will pass back a Boolean as to whether the user should have access to that channel or not. Sorry, not a Boolean. Yeah, we pass back a Boolean, and if that Boolean is true, Laravel will go ahead and create an authentication token for us, which we can then pass to the WebSocket server, and the WebSocket server will verify that before allowing the user to connect. So we're now connected, and if we go back to our browser and we look in the network tab, and we look in the response section, you can now see that stuff is starting to be pushed through our WebSocket. So the green arrows are messages that I'm sending to the server, and the red arrows are messages which are coming back. So I send the subscribe action, or the subscribe event, and then Reverb is communicating back to me that I've connected successfully. But nothing still happens. If Taylor were to type now, we're still not doing anything real time. So let's go and have a look at that. And the first thing that I want to do is, if you remember, I had this action at the top that's responsible for sending the message. Well, we're calling send on the channel model. So let's go and have a look at what's happening in there. Pretty simple stuff. We pass through the message, we store the message in the database, and then we dispatch this event, message sent event. And you'll notice that the message sent event implements the should broadcast interface. And that basically tells Laravel to, anytime this event is fired, I want you to broadcast that for me. In this case, broadcast it over Reverb. We have a public property on here, which is the message model. And then all we have to do is tell Laravel what channels we want to broadcast that on. That can be one, or that can be many. In this case, we're just going to broadcast it on a private channel called channels.the channel name. And when this gets broadcasted, this is all configurable, but this is how it kind of works by default. When this message is broadcasted, you're going to get that any public property on the event itself will be made available to you via echo. So with that event's already being fired, we know that's happening, so let's go ahead and figure out how we might listen for it. So we have our channel, our echo channel created, and then we can just start chaining on methods. So here I'm going to listen for the message sent event. Again, this is configurable. You can change all of these names, but Laravel's got your back. It's going to work by default with conventions. So this message sent event is the same name as my event in the back end. And all I do when I receive that is I'm going to pull the message off the event I receive and push it into the array of messages that I have in state. And so with a bit of luck, let's try and make this a bit bigger. Jump back in here. If Taylor now says hello, we can see that message going across the WebSocket, and Jess has received it in real time. And if Jess replies with sup, Taylor gets it too. So with just a few lines of code, we're already starting to be able to wire up this UI. So let's jump into what the typing indicator looks like. So in our text editor, we have the editor itself is firing an event, a JavaScript event on key down, and we're going to use that to trigger our typing method. So down a little bit further, we have this typing method. We're going to check there's a channel, and then we're going to use this debouncer to make sure that we're not going to fire the start typing event every time somebody presses a button, because that would be a little bit expensive and not useful. We're going to debounce that, send it the first time that they send a keystroke, and when they don't send any more keystrokes for 2 seconds, we're going to invoke the stop typing event. Pretty simple stuff. What's interesting here is that we are using our channel again, but we're seeing this new method called whisper. And whisper allows us to send an event name and an object of data through. But what's interesting about whisper is it doesn't communicate with the framework at all. This just all happens in the context of the WebSocket server. So our client will send the event. That's going to hit Reverb. Reverb's going to say, this is a client event. I know what to do with this. And it's going to broadcast it across all the users connected on that channel. So we have the events firing now. And if I were to jump back in my browser and show the... I hope this is big enough. Sorry if it's not. If I show Taylor typing in here, I don't see anything because I see just typing. Oh, what have I done? Did I save? I don't. Yeah, I shouldn't need that yet. Let's try again. Okay. Maybe James is right for once. So when I start typing in here, you see on Jess's screen, Taylor is typing. And if Jess starts typing, Taylor sees that Jess is typing. And you can see the events firing back and forth across the WebSocket. OK. So the last thing we're going to wire up is the presence indicator. Now, I mentioned this is a bit different, and we actually have a slightly different component for it. We have a Reverb users component. This is just an Alpine component where we iterate over all of the users, and the only thing that's interesting to see in here is that based on the user's online status, we're going to change the color of the presence indicator. So in here, we're going to set some state using the JS directive, which makes those users available to Alpine. And then in the initialize function, we're seeing some new echo magic. So echo.join is the function that's responsible for dealing with presence channels. So it works in the same way. Presence channel is basically an extension of a private channel, but rather than When you connect to the sockets, however, rather than just connecting you and telling you you're subscribed, it gives you some information back. And we can access that information with the here method. So when I join the workspace channel here, it's going to go ahead and authorize me that I'm able to do that. And then I get this into this here method where I get past the currently online users that Reverb's going to provide us. And I'm calling a mark online method, which basically just iterates over the users and changes their online status. I also have this joining function, which allows us to, it gives us a user every time somebody new connects to the WebSocket or to that particular channel. And the leaving is the inverse of that. So we're going to mark them as offline when they disconnect. And so again, with just those few lines of code, we can jump back into our browser. And we can immediately see that Jess, myself, and Taylor are all online. And just to prove that this works, I'm going to jump into a new tab, close the old tab, and Taylor's now offline. And I jump back in, and Taylor's now back online again. So you can see that with the tools that we have available to us in the Laravel ecosystem, we can build up these really, really engaging, snappy UIs. But there's one more thing I want to show you. So if I jump back in the network tab, and I send a message as Taylor, hello. We've already seen that I have this Livewire request that I'm making. I'm making an HTTP request every time I send a message. And if you've got a busy Slack installation, those requests are going to start to build up and become expensive. And we already have this open WebSocket for which we can pass data between client and server. So is there any reason why we can't use that? Well, currently, yes, because nothing is connected to our Laravel application. We're using a third party of some description to handle WebSockets for us. But the fact that Reverb is running in an artisan command alongside our Laravel application opens up some interesting opportunities. Every time Reverb receives a message, it's going to fire off a message received event, and we can hook into that as we would do with any other Laravel event. So I have a listener here called broadcast message. And you can see that it's listening for Laravel Reverb events, message received event. We get the message which has been passed through. We can do some manipulation on that and make sure that we are getting the right event that we're interested in. And then we have the channel pass through as well as part of that event. So we can grab the channel from the database. Obviously, we would have some more protection in place, not just grab one and hope that it's there. But we can, if we've got the channel, we can then call the send method as we're already doing, and we know that that's going to dispatch an event to broadcast that message across to all connected users. So if we jump back into our Reverb component, and we jump down here to this send method, you can see at the moment that I'm just invoking the Livewire action to send that message for me. And this is a little bit gnarly at the moment. We don't have wrappers around this at the moment. I just wanted to show you what we can do now that we have this opportunity. Because we are implementing the Pusher channels protocol, we can use the Pusher SDK under the hood, which is why I'm grabbing the Pusher object directly from Echo. And I can call the send event method and pass through an event name, some data that I want to pass across the channel, and the channel name. And so now that's no longer going to send that request to Laravel. That's going to send that request to Reverb, which is also Laravel. It's kind of confusing. But that will fire off the message received event, which we're now hooking into with our broadcast message event. And we've basically implemented the same functionality. So if I now jump back in here, let's grab this network tab again. Yep, we're connected to all the channels. If Taylor now says, I don't know, what does Taylor say? Pretty good. You can see that my send message event has gone across, and that's worked its way through Reverb. Reverb's fired off that event. It just eventually made its way back to the message sent event, and that's been broadcasted to all the connected users. So with this approach, we've been able to take away an additional HTTP hop that we didn't need. Okay. Whoop. Let's jump back to general, and we'll let everyone know we're back. Oh, thanks, team. That's what I wanted. Oh, but there's one more thing. As we like to do at Laravel, we want to make these things really easy for you to use. So when we ship Reverb, there's going to be a seamless integration with Forge. Now, Taylor showed the app panel on the screen yesterday, which James has been working on, and we keep adding to that and making it better. And so Forge will have its own entry for Reverb in the applications panel. It'll be a toggle switch. You give it the host that you want to run it on, and it's going to go ahead and configure your Nginx host. It's going to tweak some settings on the server to make it optimal performance for Reverb. And of course, you want to be able to see how your WebSocket server is performing. So we're going to ship Reverb with a pulse card, which will give you a kind of real-time indication of the number of connections you're managing and the number of messages that are being sent across the channel. And I'm really, really thankful to Tim and Jess built this, because I started working on Reverb, I don't know, let's say 18 months ago. And this didn't exist, and this was the single biggest thing that I was worried about solving, and they solved it for me in that time. Okay, so that's really all I've got, aside from a short summary about what we've learned today. And probably the biggest takeaway that we can all have is that objectively Slack is better than Teams. And we've also learned that WebSockets are a better approach to listening to your kids screaming at you in the back of the car. And we've taken a really deep dive into Reverb and how it can work alongside the other tools in the Laravel ecosystem to help you build really engaging, snappy, and efficient real-time user interfaces. That's me. Check it out. Go smash some emojis. I can't do acrobatics.
What?
I can't do acrobatics.
I have questions. So first question is from Michael. He's asking, can Reverb... Marmite.
Yeah, tell me about it.
Yeah. Can Reverb be used without Livewire?
Yeah, sorry, yeah. There was just for the benefit of the talk, I built the slide deck in Livewire because it was a really nice way to show you how it works. But it can work with any, well, obviously it works with Laravel, and then any front-end stack that you're using, you can pull in Echo, and everything just works.
Great, awesome. So you probably know this guy, Mr. Luke Downing.
Oh, no.
The parrot guy.
I'm still upset he didn't give me a baking tray.
You need to ask his wife.
Yeah, that's true.
He's asking, with Reverb, will Reverb library running along your site Laravel app? Or do you need a separate app for that?
You can use either. So I don't know what's going to happen, but my gut feeling is that most applications will probably run it alongside their existing application. But for instance, I mentioned that we already, with Forge and Envoy, are running a completely separate installation and have those connect to that server, just because we want to not put extra load on our existing servers.
Great.
Oh, no.
You know, who is it? The nice way? Yeah, that guy. So from the anonymous user, will you ever eat again Vegemite?
Absolutely not. I could still taste it. It was really bad timing for you to give that to me then.
Sorry.
I didn't know that was happening, by the way.
No, not at all. So, big applause, and thank you for Reverb.
Thank you.